Hello. Okay. So, I would rather than try to send you to see other videos, I will just quickly work through this on my own. I already posted the crib, but the crib doesn't really show you how to go about this. So, we'll look at this systematically. The first set of problems involves determining how many significant figures. So, how many digits do we reliably trust? The first step is to separate these into problems that contain a decimal and those who do not. So I will put without, 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 without. Now, those without a decimal, we will take whatever the last non-zero number is. In this case, it's 3. And every number to the left of it is considered significant. This 0 still means something. It just isn't significant, quote unquote. So for as terms of reliable digits, we have 1, 2, 3, 4. This still tells us it is big. My number is raised to the 10,000th place. But I do not know for sure that this is actually 0 or not. So this guy, the last non-zero is here. So we just keep going right, left. So 1, 2, 3, 4, 5. We got last non-zero is here. So we keep going left. 1, 2, 3, 4. And the last non-zero is here. 1, 2, 3, 4. So I'm literally just counting the numbers to the left of the last non-zero. Now, any number with, regardless of whether they are full decimal or scientific notation, I am going to count the first non-zero number and work my way right until I run out of digits. So 1, 2, 3. These just tell us it is small. These 3 zeros just tell us it is small. But it doesn't tell us anything else. Since the first number is a non-zero, all of these count. So 1, 2, 3, 4, 5. Yes, I know that's a 0. And it's at the end. But it is necessary to say we know that digit to be 0. If we did not know that digit to be 0, we would have just reported 30.12 and not 30.120. So that's the difference between significance and non-significance. We'd just leave that off. But this number, if you erase that 0, it becomes 1,023 instead of 10,230. So even though this is in scientific notation, we just look at these 3 numbers. 1, 2, 3. We look at this. Here, 1, 2, 3, 4, 5. 1, 2. Doesn't matter that this is really big. All it matters is that there's 2 numbers written. It doesn't matter that this one is really small. There's only 2 numbers written. So you'd write it. You'd have 2 sig figs. Now, turning numbers into scientific notation. You are going to have a number that shows all of the sig figs that's somewhere between 1 and 10. Your scientific notation should be between 1 and 10 and it should show all the sig figs. Now, you're going to be multiplying that number by 10 raised to the power of exponent. I don't know what we're going to be turning. That all depends on whether how many decimal places to the left or to the right I have to move it. So since we just did this one a second ago, 10230, the numbers I need to know are these. So I need 1023. Now, the decimal would actually go right here. So I'm going to enter that in. And to turn this into that, I have to move 1, 2, 3, 4 places to the left. And so that means I raise this to the 4th power. We just did this one, 302. So we're keeping those 3 numbers. So we're going to write this as 302. The decimal's already shown, so we don't have to enter this, but we'd move it 1, 2, 3 places to the right. So it'd be, now when I move it to the left, it's positive. So when I move it to the right, it becomes negative, saying that this is small. Now if you type this into your calculator, you get this. You type this into your calculator just like that, you would hit enter, it would punch out that. And this guy, we just did this one. This is all 5 are useful. So we would write this as 3.0120. We keep 1, 2, 3, 4, 5. Now the decimal's already there, so we only have to move it 1 to the left. And so we're just moving that like so. Now, this is the first new one for the sheet. It with a decimal. So we're going to look at this number and move it on back. So we have 4 sig figs. 1, 2, 3, 4. 4.250. How many places do I have to move it? I have to move it 1 to the right. So it's 10 to the negative first. Last one. It's with a decimal, so we take this and keep all these. So I'd write 8.52. And in order to get that, I have to move it 1, 2, 3, 4, and 5 times 10 to the negative 5th. Now that is how you do that. Now, when it comes to the math, so you need to recognize sig figs and not sig figs. But really, we're saying when I'm adding these together, the calculator is going to give me an incorrect number. Not because the math is wrong, but because the calculator does not place any significance on any particular figure. So we need to do that for it. So I know this and this. 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 I know that, but I do not know this place. So when I'm lining this up and doing my math, I'm keeping only the position where I know both answers. I do this. I would get 50.399. You plug that into your calculator, that is what you would get. However, because I do not know this position becomes unreliable. And because this becomes unreliable, we either re-round this. either up or down, depending on whether it's above 5 or above or below. So because this is above 5, it rounds up. So that rounds up, and we'll get rid of that. So we add that 1 there. So it becomes 50.40. And that's how you'd report that answer. Same way. I know this, I know this, I know this, I know this, but I don't know that. That is a big question mark. So I look at the position. I do this math. 7 minus nothing, or whatever, is 7. 1 minus 5, I have to carry 1 over. So that becomes, what? Like 6. This becomes 0. Carry 1 over. It becomes, what? 78. And that's 0. So, now, we have to round. Yes, I know we want to say that's 7, but we don't know what this was. So, we're going to just round this up to 78.07. Once again, adding this up. If you add this next one up in your calculator, even though this one's very easy, we get it wrong because when we do this, you get, okay, 8 plus 2 is 10. So you bring that 1 over there. 1 plus 9 plus 1 is another 10. And so, actually 11. 1 plus 1 plus 2 is 4. 8 plus 2 is 10. And 1 plus 1 is 30. So 30.410. Your calculator would report as just 30.41. But because we know this place accurately, we want to keep that 0 in there. Now the next set of problems, I would highly suggest you use your calculator. We do not need to try this mental math. But okay, so you need to be able to recognize how many sig figs. If you simply punch this into your calculator, you get 429,562. However, we do not know this number that accurately. We can only know this to the lowest amount of sig figs. This is 1, 2, 3. This is 1, 2, 3, 4. So we can only know this to 3 sig figs, which means we can only keep, starting from here, 1, 2, 3 sig figs. Everything else must be rounded. So we round this to 430 period. Or you can write this as 4.30 times 10 to the second. Either or is a correct answer. The next one, moving up right along. 11.215 divided by 1.331. We do that one, and we get 8.425995492. Should I write that whole thing? No. This is 1, 2, 3, 4, 5. 5 sig figs. This is 1, 2, 3, 4. 4 sig figs. You always keep the one with the lesser amount. So we start 1, 2, 3, 4. And so I round right there. 8.426. That's 4 sig figs. Now here's a tricky one. 1080. There is no decimal point, so this is only actually 3 sig figs. This guy is 4 sig figs. So when I do this math, 13.52, I get 79.881656.8. And so I must round it to 3 places. So it becomes 79.9. All that's well and good. That's easy enough if you understand. Not always easy to understand, mind you, but easy enough. Now, in a multi-step problem, you must consider the sig figs of both steps. So sometimes it's easy, sometimes it's hard. So the first step is do this simple subtraction. This becomes 9. This becomes 1. This becomes 2. This becomes 3. 3.219. This answer is 4 sig figs. This one is 2 sig figs. So when I divide 4 sig figs by 2 sig figs, I get an answer that should be 2 sig figs. So when I do that, I get 61.903844615. I need to round to 2 things, and it becomes 62. No more, no less. Once again, this is 2 sig figs. I know you want to write down 221, but it's really just 220. 2 sig figs, 3 sig figs. So 220 times 18.5 comes 4070, which rounds to 4100. Now, hypothetically, if I had 221, it would have gone to, if I had 221, it would have gone to 4088.5, and we could have rounded that to 4090. Notice it's not too far off. It's just, this means I know this place versus I know these 2 places. And this is the actual answer. Now the last problem is a problem with actual reading and writing, where we're expected to figure out what to do. We have an empty cylinder. We have the filled cylinder. So what is the difference? The difference is the mass of our liquid. So 5.8 20 grams. We know that because we know this place on both numbers. We know this because we know this place on both numbers. Now we divide 6.64, which is 3 sig figs. This is 3 sig figs, and that is 4 sig figs. So even though we may know the mass very accurately, we do not know the volume nearly as accurately. So I do that, and I get an answer that is 0.876506024. And I round. I want 3 sig figs, so I want 1, 2, 3. I'm going to round to there, so it's going to round to 0.877. That is my final answer. Grams over milliliters. That's how I can figure that out. So I'm just basically keeping in mind as I do some simple math. Now, if you have a calculator like this, it is possible to get a sig fig calculator. If you go to apps and you scroll down to what's called Fun Science, FunSci, you have in there a scientific tool that is a sig fig calculator, which you can do that. You can go, okay, 28.120 minus 22.300 becomes 5.820, and then I divide by 6.64, and I get my answer is 8.77 times 10 to the negative first, which is 0.877 with 3 sig figs. So it is exactly possible to do all this stuff. So it's possible to do all this stuff with a graphing calculator, but that is not expected of you to use it in that way.